We're going to continue with the sum and difference formulas. And we want to find the exact value for the sine of 7 pi over 12. 7 pi over 12 is not on the unit circle. But we can use the fact that if I add these two angles together, pi over 3 plus pi over 4, I'm going to get 7 pi over 12. Now I'm going to go ahead and change that pi over 3 to a like denominator of 12 so that I can combine these two fractions together to show that there really are 7 pi over 12. So I'm going to multiply the numerator and the denominator by 4. Then do the same thing for the second fraction. I'm going to multiply the numerator and denominator by 3. So when you look at those two fractions, they're now alike. They have a common denominator of 12. So we do get the fact that we get 7 pi over 12. Now, these two angles, pi over 3 and pi over 4, are both on the unit circle. So I'm going to go ahead and create my unit circle first quadrant. Pi over 4, go up a little bit more here. Whoops. Here would be pi over 4. It has the ordered pair, square root of 2 over 2, comma square root of 2 over 2. Pi over 3, about 60 degrees, or actually exactly 60 degrees, has the ordered pair 1/2, square root of 3 over 2. And we want to find out what is the exact value for the sine of 7 pi over 12, which is a little bit more, and if I draw this in a different color here, 7 pi over 12 is really close to 6 pi over 12, which is pi over 2. Right up here, this is about 7 pi over 12. And we want to find out what is the sine value there. So we're going to use our sum and difference formulas. So we're going to go up to our sum and difference formulas in our notes. And we want to choose the appropriate formula. So the formula we're going to choose is we're adding those two fractions together. So we're going to use the third property. So I'm going to write that formula down. The sine of alpha plus beta a and b equals the sine of a times the cosine of b plus the cosine of a and then sine of b. So this is going to be our alpha, our b, our a, and this will be our b. We're going to go ahead and plug it into that formula. So the sine of pi over 3 plus pi over 4 equals the sine of pi over 3 times the cosine of pi over 4 plus cosine of pi over 3 sine of pi over 4. Now we substitute in the values. So we look for the sine of pi over 3. The sine is your y value. So we get square root of 3 over 2. The cosine of pi over 4 is your x value. And we get the square root of 2 over 2 plus the cosine of pi over 3, the x value, 1/2. And then the sine of pi over 4, your y value. Now what we do is we simplify those fractions. So to simplify them, we're going to multiply across. So we're going to multiply the square root of 3 and the square root of 2, giving us square root of 6. And then the square root of 1 times the square root of 2 is the square root of 2 over 4. Now we can add those two fractions together because they are alike. So we're adding those numerators. So the exact value for the sine of 7 pi over 12 is this rational expression. All right, Another example, find the exact value of the expression, the tangent of pi over 3 plus pi over 4. So we're going to use our formulas. Notice that we're working with tangent and we're adding the angles together. So the formula we're using in this example is right here. So we want to take the tangent of alpha plus beta. So I'm going to write the formula down. So the formula is the tangent of alpha plus beta, which equals the tangent of alpha plus beta, over 1 minus the tangent of alpha times beta. Now we think about the unit circle. The unit circle has those ordered pairs, x and y, which represents the cosine and the sine. Well, we have to do a little bit of work to get the tangent. So let's start with pi over 3. It has the ordered pair 1/2 square root of 3 over 2. So to find the tangent, I'm just going to go off to the side here. To find the tangent of pi over 3, we have to take the y-coordinate over the x-coordinate. So we're going to take square root of 3 over 2 and divide it by 1/2. So to simplify that, we're going to keep, change, flip. We're going to keep the square root of 3 over 2, change it to multiplication, and then flip that to 2 over 1. And then I'll multiply across, and we get the square root of 3. So that's going to go into our formula in a little bit. Now we need to find pi over 4 and find the tangent. So here's pi over 4. It has the ordered pair square root of 2 over 2, comma, square root of 2 over 2. We have to divide them again. We want to find the tangent of pi over 4. So we're going to take the y over the x. So we're going to take square root of 2 over 2 and divide it by the square root of 2 over 2. Well, we're just going to get 1. Now we're going to use these two numbers that we just found in our purple formula. So here we go. So it's asking us to find the tangent of pi over 3 plus pi over 4. So this is our alpha, and that's our beta. So we say the tangent of pi over 3 plus our tangent pi over 4 all over 1 minus the tangent of pi over 3 tangent pi over 4. So let's sub in those red and green values. So the tangent of pi over 3 we found to be the square root of 3. The tangent of pi over 4 we found to be 1. In the denominator, again, substitute in square root of 3 for the tangent of pi over 3, and then 1 for tangent of pi over 4. What we have is a rational expression that we need to simplify. So I'm going to change this denominator to 1 minus the square root of 3. Now, earlier in our course, we learned about denominators and having to rationalize denominators when we have a radical. In this case, we have a square root. And so we have to multiply the numerator and the denominator by its conjugate. All right, so here's where we're at. We want to FOIL the numerator. So we're going to get the square root of 3. So that's first. Outside, square root of 3 times square root of 3 is 3. Inside, 1 times 1 is 1. Last, 1 times the square root of 3 is the square root of 3. Denominator. We learned early in our course about multiplying rationalizing denominators. You only have to do the first and the last. We call that cheater foiling. So we're going to take first 1 times 1 is 1, and then outside or last is negative square root of 3 times positive square root of 3 is negative square root of 9, or negative 3. Continue simplifying. 3 plus 1 is 4, and then these two terms are alike, so we can add them together. 2 square roots of 3. In the denominator, 1 minus 3 is negative 2. We can continue simplifying. We're going to take out a greatest common factor of 2. So we're left with 2 plus the square root of 3 all over negative 2. Why we want to take out that 2 from the numerator is we now have a common factor. So this 2 and that 2 will cancel out. Now we still have the negative in the denominator, so we're just going to bring that up to the numerator, and that would be our final answer. If you wanted to distribute that negative through, you could. So that's the exact value for the tangent of those two angles adding together.